So I very much like to welcome Povilas. He's come from all the way from Aalborg to join us today to tell you something about his job and what kind of competencies he's using in his job. And he will present to you, and then he has a small assignment that you are going to work with for like 15 minutes, and then he will tell you how he solved this assignment in the real world out there. So the plan is,
it's just 20 minutes of more or less introducing the different things I've encountered. It's not that of an extensive experience. I just graduated like a year and a half ago, but there's still been a pretty different tasks that I had to take on. So just I'll tell you about it.
Yeah. So
my name is Povila and I come from Lithuania. Basically graduated just in January 2014. Besides of working at Loop and Aarhus, just for my own interest, I took a number of online courses which I highly recommend to anybody who has extra interests in some particular field to just browse the web, and it has endless resources which actually kind of helped as well me to get the job and get the practical placement at the same time, because my main interest was sustainability and ecological constructions. And in the words of my boss, he just said, tell them that if they want to get a practical placement at Loop Architects, they just have to be interested in sustainability. And usually many employers work in a bit of a similar way, because there's such a big number of constructing architects. There's Danish line, there's international line. You have to go into some field that you feel you're a bit more interested in, that you can build up some knowledge and just get yourself a little bit different from all the massive people that are trying to get exactly the same job, the same practical placement. And as I tell you, the internet is a perfect place for it. There's so many different things in there, and you can just do it on your own time, on your own pace. There's no constraints about it. So I highly recommend to take that course. And this is one of my first projects that I worked on. It's actually started on my practical placement. It's renovation of the 70s villa in Aarhus. Turned out a little bit different from the first plan as it was, and I think the client, they really wanted some ecological construction that has so many ideas and so many wishes, but eventually as it usually ends up, it was the budget that dictated the design. I think it changed maybe 3 times, and the external materials changed so many times. I'd say it's a very big thing to be aware of when designing anything, to get the hold of the costs. And it's kind of hard to tell the clients in the beginning of it, because everyone wants the best thing for their buck. It's quite normal, and every time they're trying to push up just a little further to get exactly what they want for a little bit smaller price. So anytime you can simplify some detailing, something in the design that would cost less, that's probably the way to go. Because not that many people are going to have the actual finances to take on some extravagant designs and something that maybe just has just a tiny impact on the entire project, how it looks, but in cost-wise it turns out as a pretty big impact for them. As it turns out, in the beginning we had a bit of a plan for cellulose insulation, which eventually turned up into rock wool. That's another thing to be aware of, because I think it's quite popular these days to try and put in some eco-insulating material in the wall, but it's a different, completely different case than the price-wise. It's usually the contractors that you have to take into the account, because for them it's you just buy big amounts of rock wool insulation. It's fairly cheap, and to change that material into something else, it's just be prepared for every time you change the material or something. You have to have a pretty good cause behind it to actually just a stone case that you cannot really argue with. It's just there in their face, because every time they're just gonna try to change something into a little bit of their familiar territory. And from my experience, there haven't been a project where a contractor would try to squeeze in something that he is much more familiar with working. In our company, we usually try to take the integrated design approach. And that means that engineering a project is pretty much from the day one. It's not like a full-time working, but it's a little bit like here, that you have some consultations. Maybe you just do a design and you spend a couple of hours talking through to what can be the problems and just trying to foresee some solutions in the future. And had a different project which was not finished in Sweden, so I cannot tell that much about it, but they had a bit of a different way of working. It's more of the architect making a design, then it's passed to the contractor, who hires constructing architects, engineers. He designs all the details, and architects' involvement, it's pretty much finished from like outline proposal. They don't really do that much to it. And when our client asked us to design the building, he afterwards chose to do it in a Swedish way, to turn them the design with pretty much all the other responsibilities afterwards. And I think it was 2 weeks ago that a contractor from Sweden just wrote us and asked for a prize. Could you finish the project? Because when they actually saw it, it turned out that it takes a little bit too much out of them to solve it on their own without the involvement of the architect. So that's the best approach to working. It's integrated design. It's just definitely going to save you a lot of problems in the future, and even if you don't think that there's a problem somewhere in the project, just ask the teachers to quickly skim through it, because they can actually pinpoint you some locations which might turn out quite complicated. And that should help you in further projects. We had a bit of a pickle with the middle glass portion of the building. As you can see, it's on this part. And that was a fairly interesting thing to actually work with, because the only elements that I've been working with here was generally concrete or wooden elements, and at the size of the entire glass piece, it just rolls to the entire building in the middle, from one side to the other, completely dividing it, and the glass sheets are enormous. In that case, we just had to consult the actual manufacturers of how to do it, and working out on the tolerances and which points we can actually fix and where can you accommodate some differentiation of the production. It's quite important altogether. And in this semester, if the plan doesn't change, you usually work with prefabricated elements, so try to get out of the teachers everything about tolerances as much as you can. That turns out quite important, and it takes quite a while to work through. At least in my experience, it took us, I think, basically a month of more or less consulting and drawing different details and sections to actually accommodate the glass solution that everybody would be happy to. And that was pretty much because of the entire building. All the both sides were actually built at the time already, and then you had to accommodate the glass in the middle without really any other solution how to accommodate the tolerances. It was already built. There wasn't that much of the flexibility in the construction, so anytime you can go ahead of time and just make sure that that's going to work in the future, it would be a very important case to go. And as I mentioned to you before, one of my main interests is sustainability, and that was one of the projects that we consulted on. It was a competition by, well, Dania on mini CO2 type house. they had, I think, 4 or 5 different houses, from starting with upcycle house, where you're trying to increase the value of materials in the end, to recycle, to minimize the heat consumption, and in the end it was the mini CO2 house, where they wanted to put all the different experiences into one single house. And it's supposed to be more of exactly a type house, so you can just go into the company, take a look at the drawings, and then you pretty much tell them to build it somewhere. It's already designed, and I think we did quite many different solutions, and one of the main ways of how do you tell if the product is sustainable was trying to account for CO2 emissions and production of the materials and the usage of the building throughout its lifetime. And as you can see in the diagram, it's basically 65% of the entire building footprint that is accounted for energy use during the maintaining. It's not as much as heating and electricity for running the building. Actually, the biggest part of it, it's just the electrical consumption from just the computers, televisions, refrigerator, all your home appliances. And what we tried to do at that point was trying to accommodate quite a generous amount of PV panels into the building. And if we just take it like a thin film solar panels, which are basically mounted on the back of roofing membrane, if you change it 2 times in a lifetime of 50 years for a building, it basically pays off all the CO2 emissions from the materials, from the actual maintenance of the building. And I think it's a very strong point that you can make to any client who's actually interested in sustainability, and pretty much in any other building industry sector. If you can make a good point and base your decision on some hard data, it's very hard to argue with it. It might be more of a prejudice by the people, because some of them, they always encounter somebody who doesn't believe in global warming or something other than that, but in the end it doesn't really matter much of the motives. It's the end result that counts. If you can make something of a positive footprint, positive impact on the society, then why not to do it? Who cares exactly what are the reasons behind it, as long as it has a good outcome and benefits pretty much everyone. And if we go back to materials, there are a few quite good websites when you can actually look into different possibilities and don't have that much of a trouble. Because I think on 4th and semester you might get a bit of an introduction to Gabby, which is an LCA software, but it's fairly complicated and it takes quite a lot of time. I'm not sure it actually is worth you. You not always have that amount of money to actually do all those calculations. And basically, every time you have to calculate the quantities for the materials to do the price. And if you go to EPD Norway or Institute of Bauen in Germany, on their websites, there's a number of lists of all kinds of different environmental product declarations, and you can just take the CO2 values from there. You can just compare the different products. It doesn't necessarily need to be something very eco and green. It can be just your common day materials, but you can actually see still which one of them has a bit of a better impact on the project. And it doesn't cost anything. You can just download that documentation. I think it was the plan in Denmark until 2018 to actually introduce the environmental product declarations for all the products. But that's sort of a bit in the balance. If you talk with a lot of engineers, they think that it's fairly hard to do, because many manufacturers, they still don't have an environmental product declarations. And if everyone starts to do it, there's just not enough specialists to actually reach the 2018 deadline. So it might take a while, but it's a thing that's going on now. Even some of the manufacturers like Gyprock, you can download the EPDs from the website. Some of them, they don't publish the information, so you can just write them and ask. They can be pretty difficult when giving out that information, but I think the thing that helps usually, if the product claims that they are good, they are sustainable, then if they don't have an EPD, then there's something wrong with it. It's a pretty clear tell. And that was the things that we're using now, and I think one of the main things that we are looking into every time we are choosing a material. For this particular building, we actually found the Yutong Energy Plus blocks, which were just cradle to cradle certified the same year. And comparing it with different outcomes, for example, just a cavity wall of aerated concrete, some polyurethane foam, and the brick wall, it actually turned out 3 times more energy consuming to produce than just the blocks. And it turned out it was the same thickness, it had pretty much the same properties, but the actual outcome is quite impressive. If you just have time or will to go through it, then I would highly recommend try and look into the different materials that you can find on the market. And that was same case that we presented to the client for actually 5 different houses, because they had a bit of a difficult time with dealing with all the concepts of sustainability. So what we decided to do, we took the same basic house that they designed and put up all materials that are generally used, with just facing brick, the common insulation, pretty much everything that you just get standard off the market. And that was actually where it ended up. And with the use of energy, it was by far the highest impact of any possible combinations when building a house. So that was pretty much the keystone for how we tried to make it appeal to them, and taking different options for 2015 energy class, 2020 energy class. It's somewhat confusing to actually see on just the 2020 has such a higher impact on the material quantity, the insulation amount that you have to put in to keep the regulations intact, and as I showed you before, the energy consumed for just running all your domestic appliances, not the energy of actual maintenance of the building itself, is the main impact. And so it turned out that if you just take some of the other courses, even 2015 class, it can actually turn out a little bit better if you can reduce the actual electricity consumption by the people. So every time trying to optimize somewhat daylighting, just tiny tweaks into the building. It was a similar thing as we did with the actual villa in August. We installed an openable skylight at the top, and just taking out all the mechanical ventilation out of the building. If you introduce 2 big windows on both sides and the skylight at the top, in the summer it has such a big air draft that I think it was 25 degrees or something at one summer, and we just asked them how it actually worked. Was it hot? And they said it was actually a feel of maybe 21 degrees inside. Just the perfect condition, so you don't really need to put in the fan, any kind of expensive cooling equipment. It's just to design very small, tiny things that can have a big impact. And it's the same with daylighting. If you can arrange somehow the windows in the most efficient way to put it exactly on the areas where you're going to need it, not just having pretty much a space filled in with light. You might only need the light just somewhere where you're planning to put in your working space. That's exactly where you need to maximize it. The rest of the room, it can be slightly darker, it doesn't really matter, you don't have those activities there. So this is one of the best design approaches that I can recommend you when trying to design something and optimize it as much as possible. And this is the last project that I want to talk about. It was Nordic Build Challenge of 2015, a renovation of Oslo, so-called post house. It's now more of an office block. And the entire idea of the competition was be as sustainable as possible. We actually combined 4 or 5 companies as one team. It was Schmidt-Hammer Lassen as the main architect. We were just consultants on sustainability part. Kowi as an engineers, Transolar as energy engineers from Germany, and a lot of different people that are actually going into just designing a one building. So that's again where it comes down to try and get as many out of as much out of the features as you can. It's probably the perfect way where you have so many different specialists from all the fields to actually as well in one single place where you can just tap the resources. There's so many information there, just ask and try to get out of it as much as possible. And going back to the project, one of our main ideas was as well a natural ventilation. In the entire building there's not a single mechanical unit during the summer. It's all driven by a natural airflow, which is this big glass tank coming in. If you place in some of the green areas on different facades, a bit of a green area in the middle, which basically acts as a chimney, it drags the air upwards, you get the fresh air through the facade, it's getting cleaned by all the plants inside of the building, and then all the used air is going out of the top. So some of the best approaches that you can do, it's natural ones. It takes a little bit of research to find out what works. There's a lot of misinformation as well along with it. So it takes a bit of a critical approach to rule out something that sounds a little bit fishy and might not be completely working. And I guess it's the experience where it comes in this case. I still get quite fascinated when I find some new piece of information and then you're trying to go through it, and for somebody who developed it, it's always the best case that can be. But if you can find somebody's experiences afterwards when installing something, then you can get the overall opinion of, does it really work, is it a good case, or should it be just left for the future until the technology develops. It's a similar case with the same cellulose paper insulation. In the US there were a few cases, because they don't have the same regulation of you cannot have any hidden joints of the plumbing equipment. So it's quite often just built up into the insulation layer somewhere, and cellulose, one of the main benefits of the insulation is it can take up the moisture, the condensation, and then release it afterwards during the summertime. But it can actually absorb so much water that when the pipe within the insulation layer broke, I think it was the cellulose that was completely soaked up, the wood started to rot, and because it's soaked up in the insulation, you don't see the problem. It takes a few months until some damp occurs on the wall and you actually see that, okay, you need to fix this. So it's one of the things being critical, trying to arrange the things in the best possible manner, because the same benefit while you're using it, in some case it might actually be a big drawback. And until I read that case, I was pretty fascinated by the insulation, and afterwards when you read some experiences, some practical cases, you see some photos, then you start thinking, okay, where you can actually use it in the best possible manner. So it's still, it is a good material, it can work good, but you need to be very well aware of where to use it. And we chose quite a lot of different materials for the project. And I think one of the main approaches was cradle-to-cradle elements. They had a big requirement of at least 3 or 4 cradle-to-cradle elements in the building. and you can research the philosophy on the internet. There's a good product database where you can as well see all the certified materials. There's quite a lot of them that you can get in Denmark. It's started basically from just a roof membrane, where we usually just put in a bitumen felt. And the production in Belgium, Derbigum, they actually developed a membrane which is based not on oil but on vegetable oils. It has all the same properties, it looks completely the same, but it doesn't have any crude oil in it. It's completely natural, and it can be biodegraded after specific circumstances. You have to increase some heat and so on, but in the end of its lifetime you can just get rid of it without any problems. And this is the actual product that you can get in Denmark without that much of a problem. So trying to research the different things and different approaches, it's quite useful. I think it's one of my responsibilities in my job, trying to get updated everyone on different materials that are on the market now. And this is exactly what I'm doing after this presentation. We have half a day at the office just going through all the different news that we can actually use now, trying to split it up into what can we offer to private clients who are building on here and now basis, and what is more innovative, and it might not be completely affordable now, but for some high-end competition that we can actually offer a high-end product which is a little bit hard to get at the moment. And this kind of research should pretty much always pays off, because you get some clients who want something very particular. We had a client that wanted a clay plaster on the walls and a clay floor, and it takes some research, because for me, never have dealt with anything that comes with basically a raw clay in the building. And I know the stories, I've seen some farmhouses and so on where it's actually a clay floor, but when it comes down to actually building it, it's like completely zero. And the best approach in that case is just to contact the manufacturers or contractors who are actually dealing with it. There's a company in Fyn which are actually installing different clay floors and clay surfaces on walls. There's a very good and experienced company in Germany. They're just right, they're technical experts. If you hit the right person, then he will probably respond to you and send you some information of how to do it. And I think if I was here now, that would be the thing that I would do. Because sometimes the research, and if you really want to do something with a bit of a wow factor, something completely new, you're learning, you don't have that knowledge at the moment, so trying to just politely ask somebody for information of how to do it, how to approach different problems with certain building components, building materials and techniques. It's a very good approach, and it definitely going to pay off. It doesn't take a long time. And these were exactly the sustainable technologies that we implemented in the building. And one of for me, the most interesting one was probably the ice storage in the basement, which was more or less designed to store up the energy overproduction during the times where you basically don't have the use out of overheating in the building and so on, trying to tap into that energy and store it for later when you're actually going to need to cool down the natural climate inside of it. Just use it during the night and trying to make an indoor climate as comfortable as possible. And just one of the things with it that we had a bit of a funny pickle with it. A lot of people don't really get the working principles of it. So in this case, the best thing that you can do is just to talk with an engineer. There's a lot of good ideas that you can implement, and it's the same with architects at the office. You read something, you get really fascinated by it. It seems like such a good idea. But basically an engineer with some experience can tell you why it might not be a good idea. So it takes some of the critical approach to many of the different things. Don't try to be overly critical, but have some clear mind of trying and look into things from the different perspectives. And do you have anybody in the class who had like a carpentry experience, or then try and ask the people. They have a bit of experience, they have a different approach to it as well. In my years, one of my best friends in the course was this Icelandic guy, had like 15 years of carpentry experience, so it was the best person that you can ask when the teachers are not around. Because he knows quite a lot of things. It might not be a designing and drawing stuff, but how it's actually going to work on the building side. Because when you never worked on it exactly, doing it with your own hands, it's sometimes might seem a bit overly simple to actually do it. When you're there in just the cold winter months and you have to bend some steel sheet on a curve to make a flashing, it might be a bit difficult thing to do. So every time is just have any building experience, anybody in the class, trying and ask them. Again, we come back to the CO2 emissions as one of the main parts of the project. And that was exactly my responsibility to account for all the materials in the building and different impact that may have on it. I think it was one of the first projects as well that I started on my practical placement, so it was a fairly big of a shop. And you come down through 5 to 31. It was a bit scary altogether, and it was the first time I actually done anything like it. So I would recommend, if you ever encounter something that you never worked before, somebody asked you to do it, it doesn't necessarily need to be like, okay, I don't know how to do it, but you can take up the challenge. I would say inform your boss that it might take a while to actually get a hang of it. But I think it's the best experience that I ever had in the office was actually working on these calculations, because that was something I never laid my hands on at the university. And it was a really interesting experience trying to actually do something professionally that you've never been involved in with. It takes a lot of extra time. It's not just something that you go in, sit your 8 hours in the office, and at the end of the day, okay, I'm done. It takes a lot out of you. You have to research it. When you come back home, it's pretty much you have time to sleep. Everything else than that, it's research, it's trying to get as much information about the things that you want to know. And the best time to do it, it's now. There's never a better time for it. At least in the office I don't have that much time doing all the different things. It's more of a here and now approach. Because it's still a business. When somebody asks you to do something, you have to do it in a certain time frame. And when you're still at the university, you have a little bit less of a time constraint. If you have any different interests where you would want to specialize within, I think you should have an elective subject on the third semester.
This innovation part is the elective subject.
Yeah. So if you have something that interests you, try and pick it out and delve into the subject a little bit deeper. Because from now on you should have an elective subject basically every semester. So it's the best time to find some interest within yourself, which might get a bit of a kick in the beginning, but afterwards, when you're looking for a job, you're looking for practical placement, I guarantee you it's going to pay off. Because anything that helps you stand out of the crowd of hundreds of constructing architects that graduate. It's the best thing that can ever happen. And that's just a piece of interesting information. We try and compare the different options for the building with electrical consumption, maintenance of the building, the materials, and see how different approaches for energy actually compare. And this accounts for 2010 regulation building in Norway. And we actually managed to get it down for energy consumption pretty much down to here, when including all the renewable resources. Because this result was basically reached without any solar cells, wind turbines. It was just the natural approaches to the building of natural ventilation, cleaning the air, and trying to do everything in the most passive way as you can. And I would say it's a very big payoff. As long as you can do it, and there's so much software now that you can take a look at just to the Velux Daylight Analyzer. It's quite a foolproof program to use. It takes a few goes and then you can quickly check on the daylight amounts in your building. And that's something extra that you can present on the presentation, which is a beneficial experience. It gives a little bit of an extra impression during the presentation because you take some additional information out there which is not always given to you from the teachers because their material don't address that. So anything extra that you can take out of it, it's going to be a very good experience and definitely rewarding. Yep, so I think I'm basically done with my main presentation. And unless there's some questions, we can go down to the assignment.
Any questions from the class?
Could I ask one that was asked some years ago? We had 3 people like you standing, and the question was, and you referred a lot to what you had in your education, but the question is, looking back, is there something you would have liked to see in your education that wasn't there? And is there anything in your education you think you might not have had to work with?
So there's a lot of things that I'm interested in, and in my opinion it's fairly hard to teach everything. For constructing architect, what you get here, I would say it's more than enough. If you want to specialize into something, you have to do it on your own. That's at least my own opinion. I know I had a lot of discussions with my peers in the university because there's always opinions like, okay, nobody told me about this and nobody told me about that, but it's fairly difficult to give all the knowledge at once. Sometimes you just have to take it on your own and basically be your own teacher at a certain point. And I'm not regretting anything that I get here, and I don't think I actually missed any particular piece of information. So it's more of maybe my own thing. If I was a bit too lazy at some point, then maybe I could have pushed one or the other field a little bit further, but life happens sometimes.
Well, thank you.
Exactly.
this is 30 or half a meter,
Yeah.
you're pretty much safe. Then
Okay.
you can leave the insulation exposed. If you don't have a good enough windbreaker here, then you have to cover it up with something.
Something diffusion open, something.
Yeah, you're always going to get a little bit of a wind-driven moisture into the ventilation cavity. And as long as you have a fairly good windbreaker on top of it, then you're good. And in our case, it was the cellulose insulation, so anything that passes the windbreaker, it can be taken up into the insulation and driven back later. And for now, it actually works.
What is the type of gully, and is that like custom made or you just use the standard type?
It's just the standard size downpipe and the standard size gutter. I think this particular comes from Rheinsing, and since it's the roof is divided into so many areas, that's the reason why it can be this small, because you have 4 downpipes on the building, and it's 4 different roof areas that you have to take care of. I think it was just like maybe 25 square meters of roof that comes on one gutter. It was really small areas, and that's the other thing that you might take into the account, is it really much depends on precise surface of the roof. We had a similar problem with the middle glass area, because the client, they talked about installing the gutter and actually looked into different solutions how to do it, but the manufacturer of all the glass surfaces, he just went, it's the waste of time. Because the glass is, there's almost no friction, the water gets such a speed out of it, it just skips through the gutter and it's pretty much standing there silly. So it might affect the size of your gutter when you know exact material of the roof that you're using.
Okay. Thank you very much. Yeah.